All right, so we're gonna go ahead and get started with the warm up now. We're gonna look at how to reduce some of these radicals, and then we're also gonna talk about the conjugate. So let's begin by looking at the first one. So anytime you have a question like this, where you have more than one term inside of the radical, my advice is to split it up so that you're dealing with at least one thing and not having to focus on too many things at once. So, for example, the square root of 27 x to the third, what I think we should do is take 27 and split that up from x to the third, like this. And hopefully you guys did this. So we take 27, and then we take x to the third. All right, now because we are doing a square root, we are looking for pairs. We are not looking for groups of 3 or groups of 4. We're just looking for groups of 2. So let's go ahead and split up 27. What are two numbers that multiply to 27? Well, there's really only one combination, right? 3 and 9, or 9 and 3, 3 and 9. All right, so 9 and 3. Can I break 3 down any further than this? No. What about 9? Yeah, I can do 3 and 3. And since that is a pair of 3's, that means that I can take out the number from inside of the radical. Okay, the number inside of the radical is a 3, so we're going to take that out. I'm going to come back to that in just a second. Let me go ahead and focus on the radical x to the third, which is over here. So remember, the goal is to get a group of 2. So how can I split this up so that I get a group of 2? I can do x squared and x. Very good. So I do radical x squared and radical x. Well, obviously from here I'd get like 2 x's, or a pair of x. So I'm going to highlight that just so I know that I can take out the number from the inside. So stuff that's left over would be a 3 and an x. That's stuff that we could not simplify any further, so that stays inside of the radical. So how do we write our answer then? Okay, so from here we have a group of 3's, so that means I can take a 3 out. That's a whole number. And then from the square root of x squared, I get a whole number x, so I have 3x so far. But I was not able to simplify this remaining 3 and this remaining x, so that stays inside of the radical as 3x. So my final answer is whole number 3x and radical 3x inside, or left over. Good. All right. So once again, the goal for these problems, at least when it comes to simplifying radicals, is to either create groups of 2, create groups of 3, depending on what the root is. If it's a cube root, it's groups of 3. Square root, it's groups of 2. Okay. All right, moving on to question number 2, which is what we saw on Friday. Dividing. We talked about this idea or this term known as the conjugate. What would the conjugate be for this problem? 2 minus 3 radical 2. So it's basically the denominator, but we just switched the sign. And so that means I'm going to multiply top and bottom by this conjugate. So 2 minus 3 radical 2. 2 minus 3 radical 2. Like this. We're multiplying. And now, how many terms am I multiplying together? Well, let's count them. 5 plus radical 3, is that 1 or is that 2 terms? 2 terms. 2 minus 3 radical 2, is that 1 or is that 2 terms? How much is that, guys? 2 terms. So we have 2 terms multiplying with 2 terms. We are not going to distribute. We are going to use the area model. Right? So remember, if you have 2 terms with 2 terms, that is when you use the area model. 1 term and 2 terms, you can use the distribute property. So this is the area model. Okay. So for the area model, we're going to get the following. We take 5 plus radical 3. So 5 plus radical 3, and we take 2 minus 3 radical 2, and then we multiply it to get the stuff on the inside. So we do 5 and 2 first. 5 times 2 is 10. 2 times radical 3 is 2 radical 3. 5 times negative 3 radical 2 is negative 15 radical 2. And finally, negative 3 radical 2 and radical 3 makes negative 3 radical 6. So when it comes to multiplying, it's like you're multiplying like terms. Whole numbers multiplied with whole numbers, radicals multiplied with radicals. Okay. So from here, then, we can extract the following. We have 10 minus 15 radical 2 plus 2 radical 3 minus 3 radical 6. Okay. There's not much more we can do to simplify that any further, so we're just going to leave it how it is. So this is your numerator. To find the denominator, it's even easier than that. We talked about the fact that the middle term will cancel out. So all we're doing is we're multiplying like terms in the denominator. So we're going to go ahead and multiply the following. We'll multiply 2 with 2 and positive 3 radical 2 with negative 3 radical 2. So what do we get from that? Well, 2 times 2 makes 4. And then when we multiply these two, positive 3 and negative 3 makes negative 9. Radical 2 and radical 2 makes radical 4. We can, of course, simplify that because the square root of 4 is what? 2. And then we have 4 minus 18, which gives us negative 14. Okay. So we're going to go ahead and take this, and that will be our denominator. And we are done. That's our final answer. So sometimes you will be able to cancel stuff. Well, not cancel. Sometimes you'll be able to combine stuff in the numerator. Sometimes you won't, and you'll just leave it as is. Okay. All right. I have not made your guys' test for next week, but I'm gonna start making it soon, and I am thinking that I want to do about 4 questions. For sure, you're gonna see something like this. All right. So you're gonna see a question like this. You're gonna see something with simplifying radicals. Well, that's already 2 questions, and then you're gonna see 2 more questions based on 208. All right. Okay, so let's talk about what 208 will look like. 208 is kind of long. I will try to write as many steps as I can just to make sure that we are able to follow along. And I'll try to keep my notes looking nice and neat so you guys can follow with that. Okay. So if you need to flip the page, go ahead and do that. But let's get started with the next part. Okay. All right. So the goal of 208 is solving. Now, to solve means you're getting an actual solution, like x equals blank, x equals another number, whatever. You're not just simplifying; you're actually solving for x. So let's write down the following. Here's your first example. You want to solve. You want to solve the following. Radical negative 10 plus 11x is equal to x. Okay, so write this down. Radical negative 10 plus 11x equals x. All right. I'm going to write some steps on the side So please go ahead and write these steps as well. So your first step is the following. Your first step will be to isolate the radical. What does the word isolate mean? Isolate the radical. What does that mean? To get it by itself. Good. So the goal is to get the radical by itself. In this problem, we don't have to do that first step because there are no other terms that are with the radical. You'll see later on we will have to include, or we will have to do that first step. So the first step is to isolate the radical. The second step, how do you guys think we're going to go about this problem if we have a square root? What do you think we're going to have to do with that square root to get rid of it? We have to square. So the second step will be to square both sides. So your second step after you isolate the radical is to square both sides. All right. I'll give you the next step once we get to it. Let's stick with that second step for now. So let's go ahead and perform the second step. We're going to square both sides. So that means I'm going to take radical -10 plus 11x equals x, and I'm going to square both sides. Now for this problem, it's not too much of an issue to square because since there are no extra terms with the radical, if squaring it just means that we're getting rid of the radical. So that means we're going to take the stuff from the inside and just kind of write them without the radical. So we'll be left with -10 plus 11x equals x squared. Okay, so that's what we get. All right. So far we've done step 1, step 2. Let's go ahead and write or do step 3. Step 3 is to rewrite as a trinomial So once again, step 3 is to rewrite as a trinomial. What does that mean? Basically means rewrite as a an equation with 3 terms. All right, so you'll notice we have 2 terms on one side, 1 term on the other side. To rewrite as a trinomial means get everything on the same side, get all 3 terms together. So how do we move this x squared from this side to this side? What are we gonna have to do? Sorry. Good. We're gonna subtract by x squared to get it to this side. So we'll go ahead and do that both sides. So minus x squared and minus x squared. And so that'll give me negative x squared negative x squared plus 11x minus 10 equals 0. Okay. So kind of going along with this third step of rewriting as a trinomial, you can write in parentheses set equal to 0. Because that's kind of combined. So obviously when you move everything to one side, the other side will be left at 0. Okay. So we have the statement negative x squared plus 11x minus 10. And there's a little bit of an issue. And the issue here would be that the leading coefficient is a negative. Typically, we don't like that. We don't want to have a leading coefficient of a negative. So that's going to make us have to do this fourth step, which is going to be to factor. And basically what that means is multiply or divide by -1. Okay. Now the reason why we want to do this step of factor, this step 4, is because if we didn't, then we'd have to use the Xbox method to solve this, which is not too big of an issue, but having to do the regular X versus the Xbox method is going to save you time. So anyway, what that step 4 is going to do is it's basically just going to change the sign of everything in their trinomial. So negative x squared becomes positive x squared. Positive 11 becomes negative 11. And negative 10 becomes positive 10. That's all that you really have to do with this step 4 of multiplying by -1. Okay. So now we can continue factoring. This is a basic, trinomial. It's not much to it. We're going to go ahead and factor this with the giant X. So we throw a 10 in the top, negative 11 in the bottom. And we're looking for two numbers that multiply to positive 10 and add to negative 11. Because our product is positive and our sum is negative, that means both numbers will be negative. So -1 and negative 10. So those will be your two numbers. So these two. And that means we can rewrite this as a product of the following binomials. I'm going to zoom out real quick. This is where step 5 comes in. ZPP stands for zero product property. It just means solve for x, like set it equal to 0, solve for x. So what that means is you're going to take x minus 1 and set that equal to 0. Then take x minus 10 and set that equal to 0. And the goal is to solve for x for each one. So what is this first x going to equal? This first x is positive 1, so x equals 1. And then this second x will equal what? Positive 10. All right. So overall, not too bad. This next step, though, this is the next step that I know I'm going to get a lot of people upset with. The next step is to test your solutions. Now, the reason we want to test solutions is because we have extraneous solutions sometimes to account for. I know you guys remember a little bit about that. We talked about extraneous solutions, meaning when you solve it, like you get a solution, but when you plug it in, it's not a true statement. And so oftentimes you'll run into that. That's why it's important to test your solution. If you plug it in and you notice that it's not working, then that means that it's an extraneous solution, and then we don't want to use it. We just want to use the ones that actually give us an answer. So let's go ahead and do this part here on the side. To test the solution, let's start with when x equals 1, and then we'll do when x equals 10. All right. So when x equals 1, we're going to take our initial equation, which was, let me rewrite this. It was radical -10 plus 11. And in this case, we'll plug in 1 in place of x. And this is supposed to equal x, or in this case, 1. And then I'm going to do the same thing on this side. -10 plus 11 equals, except on this side we're doing 10, 10. Okay. All right. So obviously 11 times 1 is 11. And negative 10 plus 11 will give you 1. So in this case, we have the square root of 1 equals 1. The square root of 1 is 1. So we get 1 equals 1, which is true. Checks out. If you're wondering how I went from this first step to this part right here, 11 times 1, once again, 11 times 1 is 11. Negative 10 plus 11 gives you 1. Same as 11 minus 2. On this side, we do the same steps. This is going to give us negative 10 plus 110 equals 10. So negative 10 plus 110 is the same as 100. What is the square root of 100? 10. So 10 equals 10. And that checks out. So in this case, both of our solutions work out. Okay. All right. And so that's all. Those are all the steps that we have. There's a total of 6 steps. Overall, not too difficult. It does become a little bit more challenging if you were to have extra terms, and that I'll show you what happens when that is the case. I'll show you that in the next example. We have a total of about 4 examples to get through, so we'll definitely be able to do this before the break. All right. Is anyone still writing this? Can you get some extra time to finish writing this down? All right. So let's move on to the next part. I'll do it here on the side. So I'll do it here on this side, so that way I don't have to rewrite the steps. But you guys can rewrite the steps if you need to. Your next example is the following. It's radical 11 minus 2x minus x equals 4. Negative 4, sorry. Negative 4. So once again, the problem is actually, here, I'll do this. Sorry I'm moving it so much. I'm going to set it up real quick. Give me 1 second. Copy and paste. There it is. All right. Once again, this is the problem for you guys. Radical 11 minus 2x minus x equals negative 4. All right. Let me move this a little bit to the side. I feel like I'm a little cramped. All right. Okay, let's start with the first step. So if we look at the first step is to isolate the radical. So I want to get radical 11 minus 2x by itself. How do I get radical 11 minus 2x by itself? I'm going to need a little bit more participation from you guys. So I'm just going to start calling on people for this. Okay, so once again, first question is how do I get radical 11 minus 2x by itself? Let me hear from Marley. How do I get this by itself? Is it by itself right now? No. What's next to it? Yes. So how do I get rid of negative x? What's the opposite? Positive x. So we're going to get rid of that by adding x to both sides. That's the first step. So first step, isolate the radical means move like terms away from it. All right, so it's kind of like the opposite. So we get radical 11 minus 2x equals x minus 4. All right. So let's look at the second step. The second step is to square both sides. All right. So I'm going to go ahead and square both sides, and this is what's going to happen. So I square both sides. And now the first half of the equation, I just cancel out the radical. So I'm left with the stuff on the inside. So 11 minus 2x. But now I have x minus 4 squared, which is x minus 4 times x minus 4. Okay. There's a little bit of an issue with that. Because I can't just multiply x with x and negative 4 with negative 4. For this, I have to use an area model. So I have to use an area model. All right. So we'll go ahead and throw that into an area model real quick. X minus 4, x minus 4. Fill that out, please. Fill out that area model. Should take you a few minutes. All right. X times x. What do we get with x times x? Noah, x times x. X, not 2x, x squared. Good. So we get x squared. What goes in this box right here, Anaí? What goes in this box? Negative 4x. Same thing for this box, negative 4x. What goes in this one right here? Negative 4 times negative 4. It's a Myra. Negative 4 times negative 4. It's positive. Positive times, not plus. 4 times 4. 16. So positive 16. Okay, so we get the following. We get x squared, negative 4x plus 16. Let's rewrite that over here. So we'll rewrite it. So we get 11 minus 2x equals x squared minus 8x plus 16. If you're wondering how I get 8x, it's because I combine these two. So negative 4 and negative 4 makes negative 8. All right? Okay, cool. So check step, what is it, step 4? Is it step 4? No, step 3. So rewrite as a trinomial. I have too many terms right now. So I want to move everything to the same side to get like just one trinomial. Otherwise, I'm going to have a trinomial and a binomial. It's too many terms. I'm going to move 11 and I'm going to move negative 2x. How do I move 11 and negative 2x? What do I have to do with 11 and with negative 2x to get it to the other side? So I subtract 11 and then I add 2x. So subtract 11. 11 is a whole number, so I'll subtract that from 16. 2x, I'll subtract that from its like term, or sorry, I'll add that to its like term of 8x. Okay. So what do I get from completing negative 8x plus 2x? What's that going to get me? Minute, what's that going to get me? Negative 8 plus 2. No, not negative 10. Are you close? Go the other way. Negative 6. So minus 6x. And then 16 minus 11. What do I get from that? Kayla, 16 minus 11. 5. Plus 5. Okay. All right, so now we have a trinomial. And at the same time, it's set equal to 0. So we are good with step 3. We can move on to step 4. We do not have a leading coefficient like the first problem. So we don't need to multiply by negative 1. Gentlemen. Joel. So that means we can move on to factoring. All right, so we're going to go ahead and factor this using a giant X. Throw the 5 up here and the negative 6 down here. Just like before, your top number is positive, your bottom number is negative. So that means that the two numbers are going to be negative. Give you guys some time to think about what that's going to be. So the two numbers that multiply to 5 and add to negative 6 are what? Negative 5 and negative 1. So we have x minus 5 and x minus 1 equal to 0. And that means x equals 5 and x equals 1. Now, we just have one final step. Actually, I'm not going to circle my answers yet because I don't know which one of these won't work. So one of these might not work. So anyway, so we have x equals 5 and x equals 1. We have to test our solutions to figure out if we have any solutions that do not work. Sorry. So let's do that in the next step. I'll do that over here. So when x equals 5, and then we'll do when x equals 1. And you're going to have to refer back to the original problem for this. So let me zoom in. Okay, so when x equals 5, we have the following. We have radical 11 minus 2x minus x equals 4, or negative 4. And then this one is 1 and 1. So let's start with this one. 11 minus 2 times 5. What is 2 times 5? 10. So this is 11 minus 10. So 11 minus 10 minus 5 equals negative 4. 11 minus 10 is 1. What's the square root of 1? 1. What is 1 minus 5? Negative 4. So negative 4 equals negative 4. This solution works. I'll zoom out so you guys can write this down. So once again, this solution works. Let's test out the next solution. See if that one works. All right. 2 times 1 is 2. So this is 11 minus 2, which is going to give you 9. This is radical 9 minus 1 equals negative 4. Well, the square root of 9 is what? 3. 3 minus 1 equals negative 4. Well, 3 minus 1 gives me 2. Is 2 equal to negative 4? No, these are different numbers, so this is not true. This is not a solution. Not true. So what does that mean? It means that your solution, your actual solution, is only going to be 5, not x equals 1. X equals 1 we're going to cross out because that did not give us a true statement. Okay. All right. I'll let you guys write that down. And then we'll do one more question. Now this next question, like as always, I save the best for last. All right, this next one is it's a fun one. All right, so we'll do one more question and then we'll take our break, okay? How are we doing so far, you guys? Doing all right? Okay, cool. Doing pretty good. All right. You guys ready? Okay, let's do it. Last question. All right, let me copy this down before I forget. All right. Okay. Let's write this down. Here's your last example. Radical x minus x plus 10 plus radical 3 minus x is equal to 5. All right, it's a fun one. All right, there's one small change that I'm going to have you guys make for the steps for this one. So with step 1, we don't want to isolate the radicals. We want to separate. So change the word isolate to separate. Okay, separate the radicals. So well, you could leave it as isolate as long as you know that you want them like on opposite sides. Okay. So when we have radicals on the same side, we want to separate them so that we have radicals on one side and radicals on the other, assuming you have more than one radical. All right. Let's go ahead and take care of that. So I want to move radical 3 minus x, and the way I'm going to do that is I'm going to subtract it to the other side. I'm going to subtract it to the other side. And so that's going to leave me with radical x plus 10 equal to 5 minus radical 3 minus x. All right, we can stick with step 2 how it is. Step 2 is to square both sides. So let's square both sides. Okay, so we square both sides. Now, when we square the first side, the radical is going to cancel out, so that's easy. X plus 10. When we square the second side, not so easy. Because we don't just have the radical, but we also have the 5 in front of it. So 5 minus radical 3 minus x to the second power is the same as rewriting this 5 minus radical 3 minus x times 5 minus radical 3 minus x, because we have a pair of them, right? Because we're squaring, it's like we have two groups of these. It's going to get a little bit messy. But we've done this before. We have two terms multiplying with two terms. That's going to call for what? How do we multiply this together? An area model. So this calls for an area model. So this calls for an area model. We'll do this down here. Five minus radical 3 minus x. 5 minus radical 3 minus x. I'll help you guys fill out the area model. It's actually going to be a little bit easier than you think. And I'll show you why it's easier than you think. So let's start with the easy numbers. 5 times 5. What is 5 times 5? 25. Oh, it's easy. We have whole number 5 multiplying with radical this. We can't really multiply whole numbers and radicals, so we'll just rewrite it as like just putting it together, right? So this will give us negative 5 radical 3 minus x. Negative 5 radical 3 minus x. And we have the same thing here, 5 and negative 3 minus x. So that'll also give us negative 5 radical 3 minus x. And then lastly over here, we have radical times radical, so we can just kind of multiply the stuff on the, we can just kind of take out the stuff from the inside, because we have a pair. So if we have a pair, we could take out the stuff from the inside. So this will give us 3 minus x. Okay. 3 minus x. All right. So that's the area model. We're gonna go ahead and take out the stuff in the area model, and we're gonna combine like terms. So we have the following: the 25 minus 5 radical 3 minus x minus 5 radical 3 minus x plus 3 minus x. What terms can I combine? We'll start with the easy ones. Let's combine the easy ones first. What can I combine 25 with? The 3. So I'm going to highlight just so you guys can see what I can combine together, okay? So 25 and 3. Now we can focus on the more challenging terms to combine. Negative 5 radical 3 minus x and negative 5 radical 3 minus x, they both share radical 3 minus x. So this would be like combining negative 5 with negative 5, negative 5x with negative 5x. Negative 5x and negative 5x make negative 10x. So in this case, I'm replacing this stuff with an x. What I want to show you guys is the following: that we can combine this with this because they have the same radical. So 25 plus 3 is 28. And this is going to give us negative 10 radical 3 minus x minus x. All right. We're doing okay so far? Okay. Let me zoom out real quick. So I'm just going to go ahead and bring this down now, so that we can have, our statement. X plus 10 is supposed to equal all that stuff right there. All right. So here's the thing. Do we still have any radicals left? Yes. So that means we have to kind of restart. I'm telling you, there's a lot of steps here. We have to restart to make sure that there are no radicals left over. So we're going to isolate the radical now. Remember, originally it was separate the radical. Now it's isolate the radical. So now we're working to get radical 3 minus x alone. So the first thing that I'm going to do is, well, I'm going to move the 28. And I'm going to move the x to the other side. So plus x minus 28. Okay. So that'll give me 2x minus 18 equals negative 10 radical 3 minus x. Okay. All right. So at this point, we can go ahead and square both sides. Okay. Let's go ahead and do that. Actually, no. Let's do one step before we do that. So you guys notice how we have 2, 18, and 10? What does 2, 18, and 10 have in common? Think of like factors. What does 2, 18, and 10 have in common? They have a factor of what? Of 2. So we're going to go ahead and get rid of that factor first. Let's divide everything by 2. So that'll give us x minus 9 equals negative 5 radical 3 minus x. I'm going to list out the step that I did here. This step is called reduce. Just because we're kind of adding extra steps at this point, or like we're kind of filling in some steps in between the other ones. Here's the next step that you're gonna write down. Ready? You're gonna square both sides. And there's a rule I want you to write down, because when we square right now, it's gonna be a little bit different than when we squared earlier. This is the rule I want you to write down. Please write this rule down. So this is known as the power rule for exponents, or at least it's similar to it. Basically, you can distribute the exponent to all terms inside of the parentheses. So a, b to the n, I can rewrite as a to the n times b to the n. In this case, all I'm doing, or all I'm saying here, is that I can put that exponent with each term. And so this is what's going to happen, or why we're doing that, okay? So obviously we want to get rid of this radical here, which is going to require us to square both sides. So we'll have x minus 9 times x minus 9. But on this side, on the right side, is when we're going to kind of use that property. So negative 5 squared, I'm going to rewrite that. It's going to be negative 5 squared times radical 3 minus x squared. So this is where that property is going to come in play. I'm going to move this to the side. All right. So obviously you would have to use an area model for this first half, which I'm going to skip that right now. You guys can do that on your own if you wish to do it. Just know from this you're going to get the following: x squared minus 18x plus 81, and that's going to equal 25 times 3 minus x. Right? How do we get 25? Well, negative 5 squared is 25. How do we get 3 minus x? When you square this, you're going to cancel the radical, and you're going to be left with the stuff on the inside. We're almost done. Let's distribute this. Times 3 is 75. 25 times negative x is negative 25x. Now this is starting to look a little bit more, solvable. You can kind of follow the next step, which is to get everything to the same side. Give you guys some time to write that down. The goal is, however, to get a trinomial. Do we anticipate what the next step will be? Factor. All right. So if you're done writing this down, attempt factoring it on your own. I'll put up the steps for that in just a second. See if you can factor this on your own first. So two terms that multiply to 6 and add to 7 are 6 and 1. So x plus 6 and x plus 1 will give you x equals minus 6 and x equals minus 1. All right. We do, however, have to test our solutions. So I'll hold off on that until you guys are done with this part. Okay, so let's test our solutions. We have x equals negative 6 and x equals negative 1. So let's test the following. When x equals negative 6 and when x equals negative 1. So first, when x equals negative 6, we have negative 6 plus 10 plus 3 minus negative 6 equals 5. And that'll be negative 1 plus 10 plus 3 minus negative 1 equals 5. Should be following along, gentlemen. Thank you. So this will give us the square root of 4 plus the square root of 9 equals 5. That's 2 plus 3 equals 5, which checks out. So at least the first solution of negative 6 checks out. And we have the square root of 9 plus the square root of 4, which is essentially the same thing. So 3 plus 2 equals 5. 5 equals 5, so that checks out. So in both scenarios, we get a true statement when we check our solution. So that means that both of our solutions are good. So I'll leave that there. I'm just going to go ahead and circle my answer. Both solutions are good. All right, it is 9:43. I'm going to give you guys till 9:55. Let's take a break.